Good afternoon, ladies and gentlemen. I believe we are ready to start the webinar on intelligent automation, the natural extension of the popular topic of RPA and BPM. It's one of the series of DataArt webinars on the modern technology, and our second webinar on that topic. We decided to make another version after we sparked quite a lot of interest with the US audience. The webinar is going to last for about an hour, and we are going to reserve last 10-15 minutes for Q&A session. You can ask your questions by using the button on the bottom of the screen. In case we won't be able, we will not have time to answer all the questions online, we promise to email you the answers in the follow-up email. In the email, you will also have the link on the webinar recording and the presentation. I would also encourage you to request a free consultation with our experts. There will be a form after the presentation. So we're ready to start. I'd like to introduce you two of our experts for the webinar today. Alex Bronstein, Principal Consulting of DataArt, focusing on intelligent automation, and Brian Jenkins, a Senior Solution Architect out of DataArt. To you, Alex.
Thank you, Alexander. Thank you, everyone, for joining us today to learn about intelligent automation. My name is Alex Bronstein. I will start by giving you a big picture overview of intelligent automation, and then I will go into various intelligent automation technologies. Then I will pass it over to Brian, who is going to talk about how to get started with intelligent automation in your organization, how to be successful, and how to scale it across your organization. Why is intelligent automation such a hot topic today? Intelligent automation is most commonly defined as robotic process automation enhanced with artificial intelligence, basically RPA with a brain. At DataArt, we actually look at it more broadly, but I will talk about that in a bit. Intelligent automation has been an important part of digital transformation. It has been helping companies meet many of the new expectations of the digital era. But given what has happened in the world over the past several months, intelligent automation is going to take an even more prominent role in digital transformation. COVID-19 crisis will turbocharge and accelerate digital transformation. There are still so many legacy business processes that involve paper documents and face-to-face interactions. All of these will be completely transformed and redesigned in the coming months and years. Success in business process automation will play a big role in determining which businesses will succeed and which ones will fail in this new environment. So what is intelligent automation? At DataArt, we define intelligent automation as the intelligent application of a broad range of technologies, both modern technologies like RPA and artificial intelligence, as well as more traditional IT technologies to business process automation. Why do we prefer this broader definition? So first, there is more to intelligent automation than RPA and artificial intelligence. We also include under the umbrella of intelligent automation technologies such as BPMS or business process management systems, blockchain, as well as process and task mining. Also, you can't forget about all the IT systems that exist in any organization. The main reason why most of these systems exist is to automate business processes and transactions. This includes core business applications that are used internally within the organization. It also includes various digital channels such as web applications, mobile applications, and APIs that organizations use to interact with customers, suppliers, and partners. Of course, it also includes all the data and other infrastructure that supports all of these technologies. All of these existing systems are going to be part of any future automation infrastructure. In fact, I would argue that the greatest gains from automation can be achieved not from implementing RPA, but by creating and enhancing digital channels. If your company is behind on digitizing its interactions with external stakeholders, that's probably where you should focus your automation efforts. If you're looking to really transform your business with intelligent automation, you have to look beyond RPA or any one technology. You have to begin by defining your business objectives and then design a solution that best achieves those objectives. What are some of the benefits of intelligent automation? When people think of it, automation, of course, the first thing that comes to mind is cost reductions. But if you ask most business and IT executives, they will not put that at the top of the list. Of course, cost reduction is very important, and many organizations have achieved significant cost savings with intelligent automation. But there are many other, even more important benefits. Intelligent automation can result in significant improvements in quality, speed, and customer satisfaction. Automated processes are less prone to human error. They are performed faster. Automation of time-consuming, repetitive manual tasks can free up workers' time to focus on more value-added activities, and of course, on the customer. Automation can significantly improve job satisfaction for the human workers and reduce turnover. It can improve availability, auditability, and security, among other benefits. So now let's take a deeper dive into different technologies of intelligent automation. We will start with RPA because it's the most popular and widely used of the modern automation technologies. But I want to caution right away that while RPA is a powerful technology and it has a place in almost any organization, there are a number of drawbacks and limitations. RPA can automate business processes, but it can't really improve and transform business processes, even when it is enhanced with artificial intelligence. If you want to fundamentally improve and transform business processes, you have to look beyond RPA. So what is RPA? RPA is software that allows a person to configure a so-called software robot that can basically perform the same types of tasks that a human being can perform using a computer. RPA robots can log into applications and enter or extract data. They can manipulate files and work with desktop software. They can read emails, they can open attachments, they can execute series of rule-based tasks. They can do conditional logic, loops. They can detect and they can act on changes in applications. They can even interact with human users. RPA can work in either attended or unattended fashion. When it is used in an attended fashion, basically a human worker launches an RPA robot on a desktop. When it works in unattended fashion, it runs in the server and it is triggered by a scheduler or by a system event of some kind. Why is RPA so popular? RPA is a very lightweight technology. It works on top of existing infrastructure and business applications. It is much quicker to implement RPA than to re-engineer existing systems and processes. It's a lot cheaper and it provides much quicker payback. RPA robots can work with any type of system, including modern web-based applications, as well as legacy desktop and terminal-based mainframe applications. RPA robots can also make API calls. In fact, when a system has an API, it is always best to have the robot use the API rather than interact with the system via a user interface. RPA can work with artificial intelligence tools and unstructured documents, but we'll talk more about that in a bit. So what types of processes are best best suited for automation with RPA? Rule-based processes that don't involve a lot of judgment are very suitable for automation with RPA. Processes that operate on structured data, although RPA is becoming better and better at working with unstructured data. High volume, high cost processes that involve many human workers and that are prone to human error will provide the greatest return on investment over a short period, over a shorter payback period. Who are the leaders in RPA space? As you can see from the picture on the left, it is a pretty crowded space. The top 3 players are UiPath, Blue Prism, and Automation Anywhere. They all have their strengths and weaknesses. We don't have time today to go into that. If your organization has not yet selected an RPA vendor, you probably can't go wrong with either of these top 3 vendors. So let's look at some of the pitfalls and limitations of RPA. As I mentioned earlier, one of the key reasons why RPA is such a popular technology is that it is lightweight and works on top of existing systems and infrastructure. This is also a weakness of this technology. When RPA automates an inefficient process, it results only in marginal benefit. One way to think of RPA is another type of end-user application. End-user applications usually exist because of the functionality gaps in core business applications that inevitably develop as business needs change. So by layering RPA on top of existing core business applications, as well as end-user applications, can increase complexity and fragility. When RPA has to heavily rely on working with legacy UI, it can become very brittle because changes in UIs, especially third-party UIs, can happen at any time. Sometimes RPA speeds up one part of a process, and that just moves a bottleneck to another part of a process. Because of all these issues, the actual returns on RPA investments are often lower than they might initially seem. So now let's turn our attention to the technologies that put the word intelligent into intelligent automation. AI and ML technologies replace or supplement human cognitive functions with machine intelligence, which fundamentally makes them great candidates for use in automation. There is no one way to classify these technologies, but from the point of view of business automation, I find it useful to divide them into 3 categories. Intelligent document processing deals with converting information found in documents, such as emails, reports, forms, of business forms of all kinds, into structured format. Natural language processing deals with understanding human language and extracting meaning and intent from that language. Conversely, it deals with converting structured information into spoken or written language. This is the technology behind chatbots and intelligent assistants. And finally, cognitive insight refers to the ability to find patterns in data and build models that can make predictions based on that data. All 3 categories of these technologies are used widely in automation. All of these technologies can be integrated with RPA robots or any other systems. Of these 3, though, intelligent document processing receives probably the largest share of attention when it comes to automation. for several reasons. Despite all the progress in automation, paper documents are still widely used. Much of the manual effort in business processes is spent on reading and analyzing documents and extracting data from documents. This is just an illustration of how many different types of documents, different types of standard documents exist in different industries. One of the advantages and reasons why IDP, Intelligent Document Processing, is so popular is that it doesn't require building a solution from scratch. When developing an intelligent document processing solution, you can choose between three options: open source solutions, machine learning as a service solutions, and software as a service solutions. On the one end of the spectrum are open source solutions. These come with prepackaged libraries and models for IDP, which help you jumpstart your project. These solutions offer you the greatest flexibility and control of your project. They can also be implemented directly into your existing applications. And big advantage of these is that they are free. On the flip side, they require expertise and qualified specialists to implement solutions. Also, these programs are not trained on large volumes of data, so out of the box, their recognition quality will be low. If your firm has to work with particularly complex and non-standard documents, or you have a very high volume process that requires a low error rate, this is probably the approach you should take. Software as a service solutions are on the other end of the spectrum. These are completely out of the box solutions. They come with easy to use APIs and require very little specialized knowledge. SaaS solutions are pre-trained on a large number of typical documents such as invoices, loan applications, etc. They should work well for many of the simpler and more standard use cases. A major disadvantage of these solutions is that they're difficult to tune, and also these solutions are not free. You have to pay for these solutions once your application is in production. The so-called machine learning as a service solutions are somewhere in the middle of the spectrum. They're easy to use and deploy, and they're pre-trained on a lot of data, and they can be customizable. They can become expensive, just like the SaaS solutions, because you have to pay for using them in production. When you're contemplating a project that involves intelligent document processing, it is best to start with to try a software as a service solution, and then try machine learning as a service solution. And if you can't achieve results that you need, move to open source solutions, assuming that you will still be able to get the return on investment that you're looking for. So let's take a look at a good example of an intelligent automation solution that combines RPA and intelligent document processing. This is a project we recently did for a point-of-sale consumer finance company in North America. This company is a leader in financing of home improvement projects. They provide financing through a network of builders and home improvement contractors. One of the project's goals was to automate the validation of loan contracts. As part of loan origination, they need to make sure that the information in the loan contract matches the information that was submitted by the builder through the online portal, and that no information is missing, and that the contract is properly signed. We had already been using UiPath RPA software to automate many of the company's business processes, but we found that IDP tools provided by UiPath did not work well for this particular problem. They did not provide the required recognition quality. And we had to come up with a solution that integrated multiple tools. This is actually quite typical of intelligent automation projects. You often need to try a number of different tools to put together a solution that works. The solution we ended up putting together combined 5 different tools. UiPath was used as the overall automation and orchestration tool. 3 different AI and ML tools from AWS, Amazon Web Services, and the custom Python script. TextRact, which is an intelligent document processing solution, is used to extract information from the loan contract as key value pairs. Recognition, which is a computer vision solution from AWS, is used to recognize whether the signature field contains handwritten text. SageMaker, which is an ML solution, is actually used by the client staff not as an ML tool, but as a front end for reviewing and validating the data that was extracted from the document. Finally, we had to write a custom Python script to locate and extract the part of the document containing the signature box in order to serve it up to the recognition service. So a couple of lessons from this project. One is that it is possible to automate part of a business process that ordinarily involves human cognitive function. And the second lesson is that you need to be creative and you need to try a number of different tools to arrive at a solution that works. So moving on, let's talk about business process management systems. Business process management systems are still widely used and still very much relevant today, but they're not often talked about in the context of intelligent automation. BPMS, you can think of them as an orchestra conductor in the organization. BPMS assign which employee, external user, or system should act at every step of a business process. They ensure that every piece of information that is generated and exchanged during a process is tracked from the beginning to end. Some of the dominant players in BPMS space are Pegasystems, Appian, and IBM Business Process Manager. Camunda is a relatively new company that provides more lightweight and componentized BPMS tools. BPMS get a bad reputation for complexity, for high cost and a steep learning curve. And this bad reputation to some extent is deserved. But today there are actually lower cost, more lightweight options available, including some open source options. Camunda is an example of that. Despite some of these disadvantages, BPMS should definitely be considered as an option for automating complex, high volume, business critical processes. So what is the difference between BPMS and RPA? So the main difference is the objective. The objective of BPMS is to re-engineer and streamline high-volume end-to-end core business processes, while RPA is more focused on automating routine manual tasks. BPMS have a much higher overall business impact. They also have a higher implementation effort and implementation cost. They have more impact and require more changes to the existing system and application architecture, more IT involvement, and a higher learning curve. BPMS and RPA can be used together very successfully, and in fact, many companies have integrated BPMS and RPA solutions. So as I said, BPMS is a tool for orchestrating every step in a business process, but not necessarily automating all the manual tasks that are involved with each step. So, so BPMS can be integrated with an RPA tool to actually automatically execute various tasks within a given step of a business process. So now let's look at blockchain and distributed ledger technology. Blockchain, distributed ledger technology, and smart contracts, terms that don't often come up in conversations about intelligent automation. But these technologies are very well suited for a specific type of automation problem, automation of complex manual multi-party workflows between non-trusting parties, or at least parties that need to independently verify every transaction and every piece of data that flows through a process. So if we look at the types of functions that smart contracts perform, we can see that they're very similar to the functions of a business process management system. They used to define multi-party workflows. They define business rules for processing transactions. They determine how data is shared between parties. And they're responsible for tracking of transaction states. These are all typical functions of a business process management system. Let's take a look at a project where distributed ledger technology was used successfully to automate a multi-party business process in the reinsurance space. The company we worked with is a market leader in reinsurance of pension plan risk, or so-called pension risk transfer. Pension plans buy insurance from insurance companies to protect their beneficiaries in the event that a pension plan's performance falls outside of some set boundaries. Insurance companies, in turn, offload some of this risk to reinsurance companies. The process can involve multiple insurance and reinsurance companies, as well as pension funds. A single insurance contract can cover tens of thousands of individual annuity policies and can be enforced for up to 50 years. The business process involves monthly updates of the data related to tens of thousands of annuity policies that underlie the insurance and reinsurance contracts, and the updates to the resulting payment obligations between insurance and reinsurance companies. Prior to the implementation of the blockchain solution, all of the administration work was manual and involved exchanging data in spreadsheets via email between multiple parties. Each party had to maintain internal systems for managing the data and performing payment calculations and reconciliations. The process was manual, very time-consuming, expensive, and prone to errors. Blockchain technology offered the best solution to this problem as it supported creation of a single source of truth about the data underlying the insurance contracts, with each participating party having a copy of the data and the ability to instantly verify the accuracy of the data. Also, all the internal administration solutions were replaced with one platform that can be used by all parties. This has led to significant process efficiencies and savings and improved the reliability of the processes. This case study illustrates a great potential for using blockchain technology for automation of multi-party workflows. It also shows that achieving transformative results with intelligent automation requires truly innovative and transformative solutions. So finally, let's take a look at a relatively new category of tools called process analysis tools. All the technologies we discussed so far are technologies that are used for automating business processes. Process analysis technologies help you understand your processes before you actually automate them, and then once they're automated, to continuously control and monitor your processes. Process modeling has traditionally been a manual process. It involves interviews with process participants, observations, and analysis of various artifacts of a business process. Manual process modeling is very inefficient. It often misses what's actually happening in a process, all the exceptions to a typical business process. The flowcharts quickly become outdated as the business process is constantly evolving. The new automated process analysis tools solve this problem. They help visualize and analyze processes based on data collected from the actual actions performed during the process. They are data-driven and they provide unbiased and actionable results, actionable insights. There are two process modeling technologies, process mining and task mining. Process mining works by collecting data generated by business applications. They take data from the system's event logs and use that data to create visual representation of the process, both the expected process as well as the real-world exceptions and deviations from the process. For this reason, process mining tools are best suited for processes that are already highly automated, where most of the work is done using business applications. Also, process mining tools work best with the established ERP and CRM systems. It takes much longer to train a process mining tool to work with custom applications. In fact, much of the competition between providers of process mining is about the number of connectors to various established software systems that they provide. The leader in this space is a company called Celonis, and Minet is another leading vendor. What are some of the use cases of process mining? It is used to optimize processes, understand what's happening inside the processes. It is used to make sure that processes are in compliance with established rules. It can also be used very effectively when migrating from one core business system to another, because it gives you insight into all of the different business process scenarios that happen in the existing system that need to be accounted for in the new system. Task mining, which is also called process discovery, works by actually capturing actions that people perform on a computer. Task mining software collects actions performed by multiple workers and uses AI to build a map and a visual representation of a process. Visualization of the process helps you identify automation opportunities, and the tool can actually generate an automated process. You can then make changes to the process as needed and deploy the process to production. So this is just a quick example of how one task mining tool works. This tool is called Discovery Bot. It's a tool from Automation Anywhere, which is one of the leading RPA vendors. So basically, the way it works is you have a process analyst that creates a discovery project and then invites workers that actually operate a process to participate and to start recording their actions. Employees, do their daily work. The tool records their actions. Employees can actually visualize what they're doing and provide annotations and comments that can be useful to the process analyst to understand what they're doing. Then the process analyst collects all these recordings from different employees and can visualize each individual one and also visualize them in aggregate to see the process in aggregate with all of its variations. And then they use it to identify automation opportunities, which they then pass on to RPA development side. And RPA development manager prioritizes these for implementation, and then Automation Anywhere can actually auto-generate a robot from the process recording that that was created with this tool. So that completes our tour of various intelligent automation technologies. And now I'm going to pass it over to Brian to talk about how to succeed with intelligent automation. Brian, over to you.
I make sure that I'm there. All right, thank you, Alex. So whether or not you are familiar with these foregoing technologies, at this point, you can likely imagine how they might apply to business or technology problems you currently face. If you begin researching and thinking about intelligent automation solutions, you would make some progress by identifying pain points to alleviate and defining a scope for a project or a pilot. A pilot may be a single project or a set of related projects, and this is a natural place to start. Oh, apologize for that. So now starting a pilot already requires some momentum. Then scaling further requires commitment and buy-in from leadership and intentional planning. In this context, intelligent automation is a longer-term process your business is engaged in, as much or more so than it is a description of how a set of tools are applied to streamline its activities. So here's a typical progression. As we've seen, adoption of intelligent automation technologies typically begins with that pilot. A pilot focuses on a single process. It establishes standards for metrics, practices for iterating and incrementally improving the solution, and setting patterns of operation. A pilot is equally an opportunity to evaluate and compare automation tools and implementation alternatives. So because a pilot does benefit from a momentum boost, many organizations seek partnerships with automation or RPA vendors and service providers that provide guidance and best practices to jumpstart the process. When deploying the pilot, the basic operations are typically owned by IT, while the continuing iterations, assessment and learning, and process evolution are owned and led by analysts and business stakeholders. An organization's intelligent automation capability does not sit comfortably within IT or within a single department or business unit. Automating more and more processes on a project-to-project, team-to-team, piecemeal basis generally will fail to deliver the full value of these technologies. And so with the outcomes of the pilot product in hand, its lessons and the experience gained from optimizing it, driven by measurements, the pilot team can present to and demonstrate to business leaders the value of the automation approach. And with leadership buy-in, this intelligent automation effort can begin to transition from a pilot to a corporate initiative, led by the business and executed by a center of excellence, or COE. The COE is responsible for aligning senior stakeholders across business units, IT, and HR, while it gathers potential automation opportunities, prioritizes them, provides guidance, or even implements solutions across the organization. And finally, as more processes benefit from intelligent automation, the COE can expand to include additional stakeholders or govern a group of COEs in a federated model. But here, let's consider an example problem and solution to sharpen our thinking. So late in 2017 and into 2018, NHS Lothian began a pilot at Western General in Edinburgh that involved attended RPA robots and machine learning models to improve their gastroenterology referral triage process. The pilot was rolled out across 6 consultant gastroenterologists who previously were triaging around 30 to 40 GP referrals a day. Of these usual referrals, over 30% of them were classified as urgent suspected cancer. During the pilot, an internal steering board directed the effort, and they had initially began by considering other specialties as well before aligning on gastroenterology. This specialty had seen a 20% increase in referrals since 2015, and this resulted in a 12-week average waiting time for patients to be seen by a specialist, with some waiting up to 52 weeks or more. They evaluated contributing factors to these wait times and found that improving the triage process would significantly address this problem. So prior to the pilot, a GP would submit an electronic referral to the specialist. The specialist would evaluate the referral to decide whether a patient should be sent to a clinic or taken in for testing, such as for an endoscopy. And even this step could take around 2 days to render a decision. They comprehended the scope of the problem by analyzing around 25,000 GP referral letters over a 4-year period, and that analysis showed that their triage process was complex, with over 120 outcome permutations with a high variability in how triage decisions were made. This variability was manifest as they had a group of specialists effectively re-triage cases to see how well those decisions aligned with the previous when significant percentages did not match. So even when facing this potentially error-prone process, the proposed solution included a set of 2 RPA robots and 2 AI models. A proof of concept NLP model was trained on previous referral data to prove that it was possible to extract the right structure to enable classifier models to make urgency and outcome predictions. And into the pilot, the 2 AI models were one for classifying patient referrals as urgent suspected cancer, urgent or routine, and another for predicting appropriate triage outcome, whether the patient should be sent to a clinic, taken in for a colonoscopy, endoscopy, both, or another test. And the 2 robots were responsible for pulling the patient medical records and booking appointments based on the model predictions. The pilot itself was conducted such that the automated triage process first ran in a shadow mode while additional training data was collected, followed by a period of allowing the automation solution to triage a cohort of urgent suspected cancer referrals subject to clinical risk management considerations. Starting this year, when the process went live for 50% of their target cohort, after 2 years of the pilot period, the solution also includes a real-time analytics dashboard reflecting referral patterns and a UI for humans to assist the RPA robots when the auto triage decisions are in doubt. The referral turnaround, even with this fraction of referrals processed, has reduced around 15% against their average week wait targets. So NHS looking at next plans to expand this approach to triage referrals for breast cancer patients. From this triage case, you can see an example of how a pilot begins, how its conditions are set. And while this process is not always precisely the same, it typically proceeds by stages of qualification, quantification, and delivery. The activities that fall under this qualification stage might start with some motivated team in a single department has some pain points, or members of leadership see problems like this measurable gap in time to referral within a health system. In this hospital system case, they then formed a group to examine these referral workflows before creating that steering board. They still selected owners of the process, met to review their workflows, determine prioritization and selection criteria, used existing tools and analytics to assess those workflows, and selected the starting case. Quantification may begin before qualification is complete, when assessing steps to automate using existing analytics. But this stage properly begins when new measurements are taken to validate the process selection. This is the stage when years of referral documents were processed and re-triaged to measure variability of urgency and outcome decisions, as well as confirm the viability of automation of their choice. During quantification, the working group or groups should define the meaning of success and key performance indicators to measure that success against. These will be revised as the pilot progresses, but they are important to set prior to development. And the delivery stage is the product or product development stage. So an automation solution that includes developing RPA robots and revising business processes still involves the common stages of software development. In particular, this development cycle should resemble agile product development, where your product is the process and not just the components you might be developing. So that means that we analyze, evaluate the feasibility of automating a process, discover business and technical constraints, risks, and document assumptions. We design based on those constraints and assumptions, develop and test the automated process and components, deploy them, integrating them as appropriate in production, either side by side, or replacing the existing process, stabilize by monitoring performance, and optimize, refining, and repeating the cycle. Not to put too fine a point on it, but it is worth emphasizing. As we saw with the triage case and pilot period of years, during which the intelligent triage agents were regularly retrained and optimized, given the nature of the application and the serious importance of accurately predicting urgency status and outcomes. The triage process becomes a product, and the approach, though perhaps not the models themselves, can be applied by other services, such as mammography or cardiology. The process can improve through feedback given by the specialists that interact with it. This here is a modified lean product development cycle of process swapped for product. If you're looking to expand the scope of your pilot, or are evaluating how to move on to automating more processes, it will be tempting to use deployed RPA or BPM platforms and add more robots to solve for manual cases in the near term. But taking a process as is and keeping the interactive steps in place is what you might do as part of a POC to demonstrate the place in your environment from some tool set. Even for a process that involves a single person that gains from automating it will come when you introduce a mix of the interactive as well as back-end modifications. The process will change. For example, maybe the GP referrals do not require a separate entry form submission as they do now. If you have a multi-person workflow to automate, you will find it will involve more back-end integrations and development. And for high-volume mission-critical processes, it will be optimal to automate these nearly exclusively in back-end systems using direct integrations. While gesturing toward moving beyond a pilot, we'd like to share some key lessons learned from recent years as intelligent automation has grown. To start, integrations with RPA are more brittle than integrations via APIs. Because the virtue of an RPA robot is that it uses a UI, the downside is that it uses UI. The UI is potentially subject to changing conditions and unexpected behavior, unlike or similar to an API, which is typically more stable. Again, avoid automating processes as is. The manual steps may come from convenience, but if more steps are automated, taken in the abstract, they may be different. Take advantage of the opportunity to improve the overall shape of the process. Maybe now you send a fax to print, and automating the following step after that printing may be suboptimal when applying OCR and AI to a scan of the fax instead of keeping the document flow entirely digital. Observe and consult with staff performing the work. Talk to the SMEs, sure, but also consult with other effective staff, like nurses or administrative support. They usually have important insights, especially with respect to exceptions. Decompose process steps carefully and log them. A human may be doing many steps as one. Automate them as many. Consider consulting automation experts instead of self-evaluating and purchasing tools. So take advantage of the momentum boost with a third-party jumpstart I mentioned. So your organization will build this muscle over time and should, but don't worry about getting there to start. Plan to communicate the goals of an automation program within the organization. People may be concerned how automation affects their work now and in the future. Reach out to them and describe the program's goals to improve their effectiveness. So after a pilot and successful automation efforts, why a COE? I mentioned that intelligent automation is a longer-term concern for a business, and that requires strategy. A common approach to leading an adoption effort is to establish a COE, and the COE is enabled by a corporate initiative. The COE is a group of leaders and experts, often a COE owner, who is a senior business stakeholder, who has senior decision-making authority, senior representatives from business units to reflect priorities of individual business units and can propagate governance decisions, senior representatives from IT, HR, compliance to provide guidance on prioritization and impact assessments on operations, all of whom will provide guidance and best practices, that automation strategy, development and support through functional groups, like attached architects, analysts, developers, data scientists, and data engineers, an operational model, performance standards, and evangelism for automation technology adoption. It's important to see the COE as cross-functional and not another silo. The final piece of advice I will share is about expanding the COE. After years of maturing and your automation practices run throughout your organization, it may be necessary to expand the central COE, enhance its structure with additional stakeholders such as a separate evangelist, more functional teams, and a steering committee, and couple this with establishing COEs within individual business units that will be coordinated or orchestrated by the COE. In the triage case, there may be a medical COE, radiology COE, emergency COE, surgery COE, and on. And with that, we are happy to take and answer questions.
Thank you, Brian. Thank you, Alex. I'm quickly scanning through the questions list, and probably will just ask them in the order they will submit it. So the question is, they would be very different. I will start with the first one. What type of background and experience do you look for when you're hiring developers for intelligent automation projects?
I can take that question. So I guess it depends. As we saw from the webinar, intelligent automation is not about any one technology. So it's going to be largely driven by the mix of technologies that will be involved in a particular project, as well as by the business objectives. A lot of times we're asked specifically about the types of skills that are required for RPA implementations. What we have found at DataArt is that it requires kind of a mix of skills, some development knowledge for sure, but also RPA developers need to wear kind of a business analyst hat as well. So we found that some of our most successful RPA developers come from the test automation background. It seems like people with experience in test automation have both sets of skills, software development as well as business analysis skills that make that make for a really strong RPA developer.
Yeah, it seems like there is a correlation. If you can find a flow in someone else's work, you probably can optimize the process very well. Thank you very much. The next question, we know that some industry are more mature in the automation topic than the other. If we talk about the ones that are already quite advanced, like for example, retail industry, where do you think RPA might help, and how would you recommend to approach that topic?
I'm happy to take that question as well. I'm not an expert on the retail industry specifically, but so it is true that retail industry is highly automated. It was the first industry to digitize its customer interactions by building online shopping sites. But we also know from personal experience of having lots of issues with customer service, lots of issues with missed product deliveries, etc., that not all is well. And these issues point to the fact that there are probably a lot of process gaps in some retail organizations. So I think just like with any company, RPA has a place within retail organizations, particularly kind of in the back office, to help with automating processes for ERP, supplier management, finance, customer service, etc. So despite a great degree of automation, there are always a lot of gaps in business processes that can be kind of that RPA can help close.
Thank you, Alex. I think we only have time for 2 questions, so I will pick some of them, maybe more technical. You mentioned that RPA solutions can be brittle. What can organization do to ensure introducing RPA robots in more reliable way?
I think I can take this one. So I think it's helpful to think of RPA robot development like any other piece of development where you care about resiliency. So for instance, it's many of the major RPA platforms might have the ability to set up redundancy, and just think of standard resiliency measures. So having monitoring is very important, where you are adding, if you're looking at the entire process and seeing where the RPA robot is inserted into the process versus other already automatic elements of the process. Consider having notifications, for instance. It's as simple as learning that when there's a breakdown, if there's a sudden environmental change, or I mentioned before about a UI change, then knowing that a step is failing and in what place, and within a certain threshold of time, notifying, say, an RPA support team that there has been a breakdown. So there's that element of observability and reaction. And there's also this element of just a standard set of resiliencies where you may have a backup, let's say a failover process as well. So I think those 2 elements are important to keep in mind, that it's not going to be, it's not a certainty that they'll continue to operate.
All right, thank you, Brian. And the last question, as we're running out of time, in your expert experience, how well do the various RPA tools perform when they have to automate reading reading from and writing to all their desktops on terminal-based applications? So it's about integration with the old technology.
I guess I can jump in. I'm most familiar with UiPath, and it generally works pretty well, but certainly not perfectly. You have to understand that the way that the RPA tools work with UIs is they actually use artificial intelligence to find different UI controls on the screen. And as with any kind of artificial intelligence technology, it doesn't always work perfectly. So sometimes to make it it work more reliably, you actually have to change make some UI changes to make the RPA tool recognize UI controls more easily. So it's I guess to summarize, it works pretty well, but it's not perfect.
All right. Thank you very much, Alex. Thank you very much, Brian. Thank you very much to everyone who is listening to us. I think it's a time for us to wrap up, and we're looking forward to see you on our other webinars. And as I promised, we will follow up with the materials and the answers to the questions that we were not able to answer later on. Thank you very much, and have a great day.